Hello student, good morning. I am Dr. K.Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I was discussing states of matter, gaseous state, part 1. And actually I am reviewing this chapter, and many things, many points I have discussed, and other points, other terms. Now today I will discuss. Now I am going to discuss Boyle's temperature. Boyle temperature. Actually I am briefing. I am reviewing. Okay, already I have discussed in details in 11th and 12th. Now because multiple choice question, I have to discuss numericals and many questions. Then just for that purpose I am reviewing the chapter. Then Boyle temperature. What is actually Boyle temperature? Now I am telling you. The temperature at which a real gas behaves like an ideal gas over an appreciable pressure range is called Boyle temperature or Boyle point. Again I am telling you, Boyle temperature, the temperature at which a real gas behaves like an ideal gas over an appreciable pressure range is called Boyle temperature or Boyle point. Next things I want to discuss: causes of deviation from ideal behavior. What are the causes of deviation from ideal behavior? Then there are two main points. There are two main points to deviate from ideal behavior. Then for that you have to consider the these things, assumptions of the kinetic theory of gases. You have to remember, just have to recall the assumptions of kinetic theory of gases, postulates, also called postulates of kinetic theory of gases. Then their first point that was considered in assumptions of kinetic theory of gases, that the volume occupied by the gas molecules is negligible as compared to the total volume of the gas. This was the point in postulates. And second point also was discussed, related to attraction, force of attraction. The forces of attraction or repulsion between the gas molecules are negligible. These 2 points, due to these 2 points, you can say are not correct. Okay, not fully correct. The above assumptions are corrected only if the temperature is high and pressure is low. Then these 2 points are the causes for deviation from ideal behavior. First, volume in assumption it was that the volume occupied by the gas molecules is negligible as compared to the total volume of the gas. But it is not like 100% not, because gaseous molecules also have some volume. Gaseous molecules, only molecules, because it can capture many large places. But all gases, if we collect together, then they will also have some volume. That can't be negligible. You have to consider. For that, I can say one correction term is used. And second, the forces of attraction or repulsion between the gas molecules are negligible. It is written in assumption. It is told in assumption, but it is not like that. They have some repulsive or attractive forces also. Hence, it will affect the pressure. Then these 2 points, these assumptions, what I discussed, the above assumptions are correct only if the temperature is high and pressure is low. Now I am telling you about the van der Waals equation. Van der Waals equation. P plus A upon B square. What is actually van der Waals equation? I am telling you. After the correction in pressure, original pressure was suppose P, but due to correction in forces, now 1 A upon B square is added in the pressure. Then now new pressure became P plus A upon B square. Correct? This is the correction in pressure. And in correction in volume, that is the V minus B, small b. Here A B square, A was small a, that is actually constant, and B is also constant. Then now new PV is equal to RT, that was the for ideal gas. Then now that ideal gas equation after the correction will become real gas equation, that is called van der Waals equation. Then now for the in the place of P you write P plus A upon B square into, for volume you will write V minus B. Then PV is equal to RT for 1 mole of gas. Then now it will become P plus A upon B square in bracket into V minus B in bracket, that is equal to RT for 1 mole of the gas. This is van der Waals equation. Now for n moles of gas, then just you have to introduce n, means with the that was A upon B square was there. Now just you n square you have to write, with A you have to write n square. Correct? Then now for the n molecules pressure will become P plus A n square divided by V square. And for volume V minus NB, only for 1 mole only B was there, for n mole NB was there. That is equal to, now you have written PV is equal to RT for 1 mole. Now PV is equal to nRT for n moles of gas. Then for here pressure, now it became P plus A n square divided by V square. That is for pressure. And for volume V minus NB, that is equal to nRT. That is for n moles of gas. That is van der Waals equation for n moles of gas. Here A and B are constant, called van der Waals constant. Actually, why here n square you have used? In volume only one n you have used, NB. But here square, A n square. Why? This is because you will use 2 times of density. Molecules are colliding with 2. Correct? Always for collision 2 molecules are required. Then how much molecules are colliding? Correct? How many molecules are colliding and how many times? Then 2 times actually is used. 2 times you have to consider. That why every time 1 n. That is here n square is considered. Okay. Now next I am telling you significance and units of van der Waals constant. What are the importance of van der Waals constant? What is the meaning of A and what is the meaning of B? I am telling you now. A gives the idea of magnitude of attractive forces among the gas molecules. A small a gives the idea of the magnitude of attractive forces among the gas molecules. Means it will tell about the force of attraction between gaseous molecules. as correction in pressure is P is equal to what you have, P plus a small p, and that a small p was an square divided by b square. Okay, question is asked, don't confuse, a small p, p plus a small p, then a small p is equal to an square upon b square. Correct? Therefore, a is equal to what? Pressure into V square divided by N square. A small p is equal to An square divided by B square. Then what is the value of a small a? By cross multiplication you will get a is equal to a small p into B square divided by N square. Then here what will be the unit? Then for the pressure you have to write atm, atmospheric pressure, atm shortcut, and the volume square is there, then L square, V square is there. Correct? Then here you have to write L square divided by N square. So if this length 2 times V square is there, correct, V square, then length into length, correct, length into length, that's why L square you are writing. And this divided by N square means mole square. Okay, this P into B square divided by N square. N is the number of moles. Correct? Then its unit will become 80. For pressure you have to write atm. For B square you have to write L square. And down is N square. Then you write mole, because N is down. Then mole power minus 2. Correct? Because N square is there. Then divided by N square, that is the per mole square, but it is a mole is in down, mole square is down, that you can write mole minus 2. If you write upside, it will go mole minus 2. Then atm L square mole per mole square also you can tell, or mole square minus 2. atm L square mole minus 2. This is the unit of A constant. That this will tell about the force. A small a tells about the force, attractive force among the gaseous molecules. Its unit is asked in examination. Then its unit, now I told you, atm L square ml square minus 2, because down is N square. N means number of mole square, N square. And now for the volume, as correction in volume, a small v, that is equal to NB, V minus a small b, capital B minus a small b, that is the volume B, but we are telling B, a small b, V minus b. Then here actually a small volume about the correction, that is a NB, that's why V minus NB you are writing. Then here what will V, a small b is equal to NB. Then what is the B? V upon N. Correct? Then here for the B you will write L, and divided by N, that is the per mole. L per mole. L, capital L per mole. Correct? That is the unit of B. Okay. A small b is equal to NB, that is a correction term, correction volume, a small b, NB. Then B is equal to B upon N. Then for the B, only B, that is L divided by mole, that you can write L per mole. Okay. Then now for some gases, what are the value of A and B, I am telling you. Okay, it will be helpful while solving the numericals. Sometimes question may be asked also. Then for few gases, I am telling the value of a small a and a small b. Means a small a is for attraction force, that is the force, attractive force, and b is for correction volume, that both are constant. Then for helium gas, a value is 0.034, and for neon gas, its value is 0.211. For hydrogen gas, a value is 0.244, and argon value is 1.35. Oxygen value is 1.36. Nitrogen value is 1.39. Carbon monoxide value is 1.49. Methane value is 2.25. Carbon dioxide value is 3.59. NH3 value is 4.17. C2H6, NH3 means ammonia gas, and C2H6 ethane gas, its value is 5.49. Cl2 value is 6.49. SO2 value is 6.71. Then this value, why I am telling? Because you will get idea that what is the concept magnitude of attractive force, whether force is between the molecules, force is less or more. Then you see in helium it is very less, 0.034. Neon little more, 0.211. Like that way, hydrogen it is increasing, 0.244. Argon again it is increasing, 1.35. Oxygen is 1.36. Nitrogen is 1.39. CO is again further 1.49. Methane 2.25. CO2 3.59. Forces are increasing, attractive forces. Ammonia gas 4.17. C2H6 5.49. Cl2 6.49. SO2 6.71. Means force of attraction is more. Hence it can be compressed easily. These gases can be compressed easily. Value is more, they will be compressed easily. But whose value is less, they can't be compressed. And sometimes question is asked comparatively, which gas can be compressed more. Okay. And now come to the B value, a small b value. That is a volume of the gas molecules, gaseous molecules volume. Okay. Not entire volume where gas is there. Total volume I am not talking, only volume of the gaseous molecules. For helium, for the same gases, its volume is, for helium gas, volume is very less, 0.0237. Correct? And for neon, its value is 0.017. And for hydrogen, 0.0266. And for argon, 0.0322. Little more, it is increasing. After neon gas, it is increasing. Helium was 0.02 volume, and for neon 0.017. Now it is increasing. For hydrogen gas 0.0266. Argon 0.0322. For oxygen 0.0318, roughly equal. It is little less only. Nitrogen 0.0391, and for carbon monoxide 0.399 more, and for methane 0.0428 more, CO2 0.0427, almost equal, NH3 0.371, and ethane 0.0638, Cl2 0.0562, SO2 0.0564. These are telling about the volume of the gaseous molecules, whose volume is less or more. We will tell. Now, very, very important things I am going to discuss. Modification of van der Waals equation in special cases. Okay, tough question will be asked only from this. Then there are 5 conditions are there. Don't take it as a easy. Okay, these are the modification. modification of van der Waals equation in special cases, and in IIT Advanced only this type of question will be asked. Now 5 modifications are there that you have to understand one by one. Okay, then first I am telling you that at very low pressure, you just to think for a van der Waals equation, you keep in mind for 1 molecules and for n molecules, already I discussed. Then only in that condition will change, that will be the modification. Then first, at very low pressure, V is large. At very low pressure, obviously pressure will be less, then volume will be more. Then at very low pressure, very low, V is large, so that A upon B and B, a small b, can be neglected. In that equation, A upon B square and B can be neglected at very low pressure. Then what you will get the equation? Then equation becomes PB is equal to RT. Means what correction you have done, that will not apply here. That correction is not needed at very low pressure. Correct? Same things you will get. One condition I told you. And this after at very low pressure, that gas behaves like ideal gas. First point I told you, modification. Now second condition you can see, at moderate pressure. This was at very low pressure. Now second, at moderate pressure, neither very less, neither very high, moderate. V is not so large. Okay, here also pressure is moderate. Then V is not so large. A upon B square can be neglected. Here also A upon B square can be neglected. Okay, only P will be there. And what about B? However, B can be neglected, so that we will have P plus A upon B square into here just I am telling you, at moderate temperature V is not so large. Hence it can't be neglected. Not very large. V is not so large. Hence A upon B square cannot be neglected. It will be there. Means P plus A upon B square will be there. Only B can be neglected. Okay, at moderate pressure, V is not so large. Hence B can be neglected. Then in the place of B minus B, B you can neglect, only B will remain. Then you will find P plus A upon B square. In the place of P, in the place of B, you will get only B, that is equal to RT. Hence you can write in another way. Same things you can write in another way. You will get PV is equal to RT minus A upon V. Because V is outside, if we will multiply the B square and B will cancel, only one down will remain, and V will multiply with PV, that is equal to RT. Hence PV is equal to RT minus A upon V. And also you can write same equation, you can write PV, you divide it by RT, both sides you divide by RT, then you will get PV divided by RT, that is called Z, compressibility, PV upon RT. This side also you can divide both. PV is equal to RT minus A upon V was there, you are dividing all by RT. Then PV upon RT you will get, that is equal to Z. Then RT will cancelled out. Second RT by RT will cancelled out. Means right hand side. And A upon V was there RT will come down, RT. Then you will get Actually Z is equal to 1 minus PV upon RT. For that you can write a Z compressibility, or you can write PV upon RT is equal to 1 minus A upon RT into V. Actually this question is asked. Don't take it an easy way. You have to remember. Now third point, third correction, third modification, third condition I am telling you. Now moderate pressure you have seen. Now at high pressure you are slowly increasing. First was low pressure, after that moderate pressure, now high pressure. At high pressure what will happen? If pressure is more, then V will be a small. At high pressure volume will be less. At high pressure V is so small that B cannot be neglected. A small B cannot be neglected at high pressure. Hence A upon B square can be neglected. A upon B square can be neglected. For pressure A upon B can be neglected because V volume is very less. But B cannot be neglected because P is high. Then A upon B will be only neglected. First term with P can be neglected. Small b cannot be neglected. Okay. Because P is high. Then equation becomes, in the place of P plus A upon B square, only P will be remaining. And for the B will be there, B minus B. Then P into, in the place of pressure only P will be there. The P into B minus B, that is equal to RT. That also you can write in other way. PB is equal to RT plus PB. That also in another way you can write. Only this you can remember. After that, same things in other way also you can write after simplification. P into B minus B, that is equal to RT. You remember, this is important. After that you can simplify. This also you can write PB is equal to RT plus PB. And also here you can divide by RT. Here also. In this case also, divide left hand side, right hand side by RT. Then PB divided by RT, that is equal to Z. That is equal to, again RT by RT will cancel. Left, that is the right hand side. Then 1 plus PB is equal to PB divided by RT. Then you will get Z is equal to 1 plus PB upon RT. Correct? Then 3 condition I told you. 2 more I have to tell. Then now 3 condition I told, that was related to pressure. Low pressure, moderate pressure, high pressure. Now 2 other condition is there. That next condition is of at high temperature. Now temperature you are considering. Okay. 4th condition you are considering temperature, high temperature. Then what will happen? At high temperature, volume increases. You know, volume increases at high temperature. That you keep in mind. At high temperature, V is very large. Then if V will be very large, then A upon B square and B can be neglected. A upon B square, B is very large. Then A upon B square value will be very less. That can be neglected. And B also can be neglected at very high temperature, because gas volume will be more. Then correction gaseous molecules will be in the same number. Molecules number will not increase, but volume will, total volume where these molecules will spread, that will increase. But B will not increase. That's why it can be neglected. Both can be neglected. A upon B square means correction of B, that term and B both can be neglected. The equation becomes like first condition, PB is equal to RT, like ideal gas. That is the at high temperature. Then already in the beginning I told you, at very low pressure and at high temperature, gas will behave as real gas will behave as ideal gas. Always remember, at very low pressure and high pressure both behaves like ideal gas. Real gas, even the real gas also behaves like ideal gas. And last condition I am telling you, in case of hydrogen and helium, due to a small size of the molecules, intermolecular force of attractions are negligible. Due to a small size of molecules, in case of hydrogen and helium, their size is very small, then intermolecular forces of attractions are negligible. That is, a small a is very small, very small. A small a value will be very small, so that a upon v square is negligible. Means first term is, correction term is negligible. Then equation becomes, in the place of p plus correction term will be not there. Only p will be there, b will be there, small b, v minus b. Then p into v minus b, that is equal to RT. That is equal to RT. What you got at high pressure, third condition, same condition you are getting in last, third and fifth. You got same condition. Same p into v minus b, that is equal to RT. Third and fifth I am talking about. Then p into v minus v, that is equal to RT. Or same way you can write PV. PV is equal to RT plus PB. Correct? Just like a third condition. Then I have discussed this 5 conditions. Then many questions are asked. Always this question will be asked because it is little difficult. Hence you should all these 5 points keep in mind. Okay. Then now I am stopping only here. Thank you. Next class again I will continue with some additional advanced information I will give. Some that will be useful in solving the numericals. Okay. Thank you.